with the probability that an event happens P, then basically the expected value or the average number of occurrences within 0 to t seconds is in P. Now, since events occur at a rate lambda events per second, then within interval 0 to t, the average is also equal to lambda t, which brings us to this very, very important equation, which is lambda t equals np. Now, as n goes to infinity, which means the number of subintervals becomes smaller and smaller, which means that p goes to 0. The probability that an event happens becomes very, very small because the subinterval becomes small. However, by maintaining this rate of arrival the same, then the binomial distribution of تذكروا, it will become or approaches the Poisson distribution, which gives you the probability that n equal nt, the number of arrivals within 0 to capital T. So this number of arrivals in 0 to t seconds equals k is basically given by the Poisson random process or the Poisson random variable, and we call this as a Poisson process. تتذكروا هذا الكل هذا سويناه في chapter 2. So the Poisson counting process, we call it counting process because it counts the number of arrivals of customers, failure of parts, lightning, internet, the number of packets arriving to an internet router, and so on. With two conditions: events do not coincide. What do you mean by events do not coincide? So there will be no two events arriving at the same time. So here, we don't assume, or it cannot happen, that at this very specific time, S1, you have two events arriving. Basically, the probability of this to happen is 0. You cannot have two arrivals at this S2. So you might have an arrival at S5 and another arrival just after a fraction of a second. But at the same time, no. So arrivals do not coincide. Arrival times do not coincide. This is the first condition. The second condition, the number of occurrences in any given time is independent from the number of occurrences in non-overlapping time intervals. So that if I take this time interval and this time interval, the number of occurrences here is independent from the number of occurrences here. ما لهم علاقة ببعض. If you take another third time interval, the number of occurrences here are independent. So you might have large number of occurrences here in the first interval, maybe small in the second, maybe small in the third, or large. We don't know. There is no relationship. They are independent. And this is what we refer to as independent increments. So the increment over time is independent from time to time. The average rate of occurrences is lambda, which gives us this equation. The probability that x of t or n of t equal k is lambda t to k e to minus lambda t k factorial. And this goes for k 0 integer basically. And this happens in 0 to t seconds. Of course, this is the PDF series of deltas, and this is the average, and this is the variance. As I mentioned, the probability distribution and of the waiting time, which is the inter-arrival time, okay, is exponential distributed. And the occurrences are distributed uniformly over any time. So within certain time interval, خلينا نروح على الصورة الثانية مكبرة أكثر. Within certain time interval, the occurrence, within certain time, the occurrence can happen at any time uniformly. طيب شباب, this is basically the Poisson random process. Now we'll take examples. Any question? We have done before the Poisson random variable, and we have gave basically or studied several examples about that, and it came in the exam and so on. However, here we are including time. That's the difference. It's a random process rather than only number of كذا and كذا. Let's have the first example. So inquiries arrive at a recorded message device, recording message device according to Poisson random process at a rate of 15 inquiries per minute. Okay, find the probability that in 1 minute time, 3 inquiries arrive during the first 10 seconds and 2 inquiries arrive in the last 15 seconds. Okay, so here we have arrival at a recording message. The arrival rate is 15 inquiries per minute. Find the probability that in 1 minute period, from 0 to 60 seconds, okay, 3 inquiries arrive in the first 10 seconds, and so basically 3 arrivals here, and 2 arrivals arrive in the last 15 seconds. So this is 10, this is 45. So here we have 3, and here we have 2. What is the probability of this to happen? First of all, we need to find out what is the rate lambda, and we need to do it in terms of seconds, or in terms of per minute, or whatever. However, if you do it in terms of per second, you have to solve everything in terms of seconds. If you do it per minute, you have to solve everything in terms of per minute. So the arrival rate per second is lambda, which is 15 per minute. So I said 15 تقسيم 60 is 60 seconds in 1 minute, which is 1/4 inquiries per second. Okay. So now we are interested in the probability of n in 10 seconds, in the first 10 seconds is equal to 3, and because it's within the last 15 minutes, which is n60 minus n45 is equal to 2. This is what basically this means. So you need to be able to translate the wording into math. We know that increments are independent increments. So basically the first probability in the first 10 seconds ايش يحصل في first 10 seconds has nothing to do with ايش يحصل within in the last 15 minutes. They are independent. And because of that, I can write this probability as the probability that n10 equals 3 multiplied by the probability that n60 minus n45 equal to 2. Multiplied because independence. Okay, which is equal to the probability that n of 10 equals 3 minus the probability that I know that the number of arrivals here minus the number of arrivals here is equal to the number of arrivals in the last 15 seconds, which is equal to the probability that n of 60 minus 45 اللي وصل within these 15 seconds equal to 2. So here we have n of 10, so basically we just replace in this equation lambda t, which is 1/4, lambda is 1/4, multiplied by t, which is 10 seconds, so basically 10/4, to the power of 3, divided by e to minus 10/4, divided by 3 factorial. And here we have 15 seconds, so basically it's 15/4 square e to minus 15/4 divided by 2 factorial. Whatever that is. أي سؤال يا شباب؟ Any question? طيب, let's have another question or exercise. Suppose that a secretary receives calls that arrive according to a Poisson process with a rate of 10 calls per hour. So every hour he receives 10 calls on average.
Yes.
What is the probability that no calls go unanswered if the secretary is away from the office for the first and the last 15 minutes of an hour. What is the probability? You need here to translate the English into math. So first of all, what is the rate of arrival, Shabab? Calculate the rate of arrival and send it to me over the private chat, please.
Okay.
Over the private chat. يا شباب quickly الله يخليكم. لو تلاحظوا هنا جالسين نتكلم عن minutes.
دكتور
We are
مسموح
interested.
الشكل عام
نعم.
النت قطع عندي، مسموح لي ارسل على الشات العام، النت قطع عندي.
لا على private chat الله يخليك. طيب يا شباب per minute ها مثل ما شايفين هنا كل السؤال is about minutes, so don't send me that it's 10. We know that it's 10 per hour. Okay. Okay, so basically lambda is 10 calls per hour. However, we are interested in minutes because the question is about per minute. After we are talking about 15 minutes and so on. So basically you can write as 10 calls every 60 minutes, which is 1/6 calls per minute. Okay, and we are interested in the probability. تفضل.
أقول is clear. How do you feel from 0 to 50? First one and this one from 60 for 45. The last
Yes.
15 minutes.
Exactly. So basically, exactly. Thank you. So it's in 15 equals ايش نحن نقول؟ no calls go unanswered. معناها ايش؟ السكرتير ما هو موجود. If the secretary is away. طيب هو it will be unanswered if nothing happens, right? If no calls arrive. Otherwise they will go unanswered. So basically go unanswered معناها you have no arrivals, no calls within the first 15 seconds. And ايش بعد؟ in 60 minus n 45 equals كم? Another 0, right? Which is equal to the probability that n of 15 equals 0 multiplied by the probability that n 60 minus 45 اللي هي last 15 minutes equals 0. Now we just replace. What is the equation كانت؟ هي لامدا بس عشان نذكرها لامدا t to the power k factorial e to so basically it's 15 which is t divided by 6. This is lambda t to the power كم يا شباب؟
minus 0
to the power 0.
e to the power 0.
Exactly. e to minus lambda t which is with e to minus 15/6 divided by 0 factorial which is 1 multiplied by هذه آخر شيء 15 صح؟ Again 15/6 to the power 0 e to minus 15/6 divided by 0 factorial whatever that is. So basically it's e to minus 15/6 يعني خلينا نقول سكوير. اوكي، اي سؤال يا شباب؟ clear. Thank you. Any other question? Okay, now we have an example about the function in general. Not about the Gaussian, not about the Poisson. It's about what we have discussed before. So we have here statistically independent, zero mean random processes, x of t and y of t. So statistically independent, zero mean. هذا معطى. Autocorrelation functions as follows. معطيني ال Rxx of tau وال Ryy of tau. Okay. So first of all, what can you say about whether they are wide stationary or not? جواب. Tell me whether x of t.
Independent, so what sensation? It statically independent, so it wide sensation.
ما لها علاقة statistically independent. x of t لوحدها. Is it wide stationary or not? x of t لوحدها يا شباب. Is it wide stationary?
Yes, Doctor.
Why?
Because we have the mean is a constant equals 0, and the Rx of x depend on tau only.
Excellent. And the same thing applies for y of t, right? Both of them they are wide stationary من المعطيات اللي أعطاني إياها. تمام؟ Now find the autocorrelation function of the process, which is W1 equals x of t plus y of t. And the same thing for the difference. And then the cross correlation function. We'll take it one by one. Some signal, which is we are interested in the autocorrelation function of the sum signal, which is RW1 W1 at t and t plus tau, which is the expected value of the multiplied by W1 of t plus t, x of t plus y of t, multiplied by x of t plus tau plus y of t plus tau. Now, when we open this up, we have expected value of x of t, y of t, right? Plus expected value of x of t, y of t plus tau, and so on. So if we simplify it or collect the terms that are, rewrite them in an autocorrelation function fashion, the expected value of x of t plus tau gives you Rxx of tau. هذا أول term. Now the second term, the expected value of y of t plus tau gives you the second term, the function of y. Now, if we take the first term, x of t multiplied by y of t plus tau, this gives you the cross correlation function. And if you take y of t multiplied by x of t plus tau, gives you the cross correlation function, however, with y first, then x. But I know that طبعا أنا عندي أول function given وعندي ثاني function given. What I don't have is a cross correlation function. But what about a cross correlation? Do I know it? يا شباب. Anybody gave me the cross correlation function? شباب. How to find the cross correlation function of x of t and y of t? He told me they are statistically independent. So when they are independent, when they are correlated, what happens to the cross correlation function? ايش cross correlation function? xy of tau equals expected value of x of t, y of t plus tau, right? Which is if independent, what happens? This is expected value x of t multiplied by expected value of y of t plus tau, right? Because of independent. Now, because they are zero mean, I get zero mean. Okay, and hence the autocorrelation function is zero. The cross correlation function, sorry. So this is zero, and this is another zero, and you end up with the autocorrelation function of the sum signal W1 equals the autocorrelation function of x plus the autocorrelation function of y, which is exponential minus cosine. Similarly, so this is basically done, the first one. For the difference signal, we repeat the same. We start with the autocorrelation function of W2, W2 at t and t plus tau, which is the expected value of this difference signal multiplied by the difference signal at t plus tau. Repeating the same by multiplying the different elements, we get basically the autocorrelation function of x plus the autocorrelation function of y plus the cross correlation function minus the cross correlation function twice, which is 0. So we have basically this. So basically, the autocorrelation function of the sum signal is the same as the correlation function of the difference signal. Same or equal. For this particular example. Now, the last thing we are interested in is the cross correlation function of the sum signal and the difference signal, which is cross correlation function RW1, W2 at t and t plus 1, which is the expected value of x of t plus y of t multiplied by x of t plus tau minus, then have the difference signal. Now, if we multiply, we have, first of all, the autocorrelation function of x. However, y here is multiplied by minus y. So we have minus the autocorrelation function of y. And then plus and minus the cross correlation functions, which are 0. And we have it this one. أي سؤال يا شباب؟ طيب, let's talk about time averaging or averages. So far, we have been talking about the moments, the average, and the autocorrelation function, and so on. However, we will talk about the ensemble average, okay, or the mean. What does the ensemble average mean? So at T1, we look at the values that the random process takes, and then we take the average. This gives us basically m of T1, which is expected value of x of T1. At another T2, we repeat the same thing. We get m of T2, right? Which is the expected value of x of T2. And the way we calculate it is we take the value here, we take the value here, we take the value here, we take the average of these values for many, many sample functions, for many, many realizations, for many, many repetitions of the experiment. لو تتذكروا ايش كانت الاكسبيرمنت مثلا ال GPA of the students, right? So for many, many students, temperature for different locations, and so on. And this is the way we calculate this. We call it the mean or the ensemble average. ليش ensemble؟ لأن احنا قلنا collection of all these sample functions is called the ensemble. Right? نتذكر هذا المصطلح. The ensemble. هذه كل التايم functions أو sample functions أو realization collectively are called the ensemble. And because of that, we call it the ensemble average. And the way we calculate it is expected value of x of t, which is x multiplied by the PDF at t. So the PDF at t multiplied by the different values that x takes, and then we take the integration. And if it is discrete, we take basically the probability that x of t equals xi multiplied by xi and sum over all different i's. Okay, هذا الانسمبل average. Now there's another average for the random process which is called the time average. التايم average بصفة عامة إذا عندي أي function هنا نسميه نحن a of this function. هذا يسموه time average. What does this? How do we calculate it? We take this function نحطه داخل الانتجرال. We observe this function from minus t to t for a certain period of time, from here to here. مثلا minus t to t. Okay? So basically we take the average, we integrate this function from 0 to t and divide by 1 over t. هذا يسموه time average. Time average of the signal, everybody knows it, right? And then we take t to infinity. معناها ايش؟ نراقب السيجنال أكثر وأكثر for a very long period of time. Okay? This is called the time averaging. So if I want to take the time average of one realization, one sample function, ما أبغى أعيد الإكسبيرمنت many times. So I take only for one realization. It could be this one. One sample function. Then I calculate the time average for that. Basically, I observe the signal from here to here, minus t to t, مثلا. Okay? So I observe it. I sum it over minus 2t, and I divide by 1 over t, 2t. And I take t very long. So basically, I observe it for a very long time. هذه معناها. T to infinity, observe the signal physically. إيش معناها? For very long time. This is what t goes to infinity. Mathematically limit, لكن physically for engineers, it means that we observe the signal for a very long time or long enough time. So the average for x of t for this time function is calculated as x bar, which is given by this. Now, if I calculate the average for another time function, I will get another x bar, وهكذا. تمام؟ الآن حنتكلم إيش معنى الافريج هذا. بس خلينا بس أول شيء نخلص الأوتو كوريليشن فانكشن. The time auto correlation function. لو تتذكر الأوتو correlation function كان العادي الانسمبل auto correlation function. We observe the signal now at T1 and at T2 and take the expected value of x of T1 and T2, which is مثل ما سوينا بالmean. However, we multiply the two values and integrate over the two PDFs or sum over the two PMFs. No, the time function, we calculated the time autocorrelation function, we look at it as, similar to what we do for the mean, the time average. We observe the signal x of t. So from minus t to t, بس ننظف So for this function, I observed from minus t to t, and I multiply x of t by a delayed version of it. أحطهم فوق بعض وأضربهم وأintegrate. هذه يسموها ال correlation function أو ال correlation process. So I take the signal from minus t to t, I multiply it by a delayed version of it, which is delayed by tau. Delayed version by tau. Okay, and I integrate over from minus t to t, and then I divide by 1 over 2t. And I observe it for a long time. So I do this averaging over a long enough time. هذا يعطيني التايم autocorrelation function. هذا this is the way we write it, which is a of x of t, a of t plus tau. a هذا هو نفس الاوبريتور اللي هو عرفناه فوق. Similarly, I can do the time cross correlation function. I look at the signal and another signal delayed version of it, and I observe it from minus t to t, divide by 1 over 2t, and then observe it for a long time. شباب, clear how to do the time averaging? أخذتوه المفروض حتى في 207. Nothing is new here. If I focus only at one sample function, time averaging is similar to what you have done in EE207. ما في شيء جديد هنا. الجديد الconcept of ergodicity. هذا الجديد عندكم هنا. What does ergodicity mean? An ergodic, a mean ergodic random process means the time function equals the ensemble. The time mean, the time average equals the mean or the ensemble mean. إيش معناها? Let's go back. This means the following. If an ensemble mean يحتاج إيش؟ نعيد الexperiment many times. So we have many sample functions. And we calculate the time, the ensemble average أو ensemble mean. اللي هو اللي حسبناه هذا هنا. The way we calculate it is this in this blue line, blue part. Now هذا هو الانسمبل mean. الآن if you have an ergodic process, you don't need really the ensemble mean. It's enough for you to observe, to run the random process only once, one outcome, one realization, and observe this realization for long enough time and calculate the time average حسب ما سويناه هنا. So calculate the time average for using long enough observation, one realization. In an ergodic random process, the average, the time average equals the real average, the ensemble average. So basically the time average of one sample function equals the ensemble mean, our real mean, our statistical mean, whatever you call it, المين الحقيقي أو statistical mean. So in ergodic random process, if you calculate the time average of one sample function is enough for you to understand or to get the time average of the average or the ensemble average of your random process. هذا يسموه ergodic in the mean or mean ergodic. Similarly, في حاجة اسمها correlation ergodic. Means that the time correlation function equals the ensemble correlation function. And we call a random process as ergodic random process if the time average equals the ensemble average and the time correlation function equals the ensemble correlation function. And we call them two random processes as jointly ergodic if each one of them is ergodic and the cross correlation function, the time cross correlation function, equals the ensemble cross correlation function. أي سؤال يا شباب؟ Is it clear? طبعا why is this important? Ergodicity is very important and it is there in many physical random processes, physically encountered random processes. Why is it important? Because this tells you that مثلا خلينا نتكلم على الموبايل فون اللي basically measuring the received signal of the mobile phone. Every time you run the experiment قلنا أنت يتغير اللوكيشن حقك, right? So basically, or you make a new call from different location. So in order to define the random process, you need to run this experiment وتشوف كل مرة على الأسوسكوب كيف شكل ال random process, and you calculate the average for every time, and then you get the ensemble average, بعدين the autocorrelation function, and so on. Now, if your signal is known to be ergodic, you don't need to do this. Simply, you need to run one call from one location. However, make it a long call. Observe this call على الأسوسكوب for long enough time, and you can calculate from there the time average, the autocorrelation function, and so on, if it is ergodic. And in most of the physically encountered random processes, you get an ergodic function, ergodic random process. اوكي. طبعا الجي بي اي حق الطلاب لو تذكروا الاكزامبل اللي سويناه, جي بي اي this is مثلا student number 1, student number 2, الترم الثاني، الترم الثالث يزيد، الترم الرابع قبله كذا، بعدين اخر شيء تحسن. مثلا عندنا كم احنا 8 semesters maximum. تمام. another student starts very bad، بعدين يبدأ يتحسن مثلا يعني. اوكي، ايش رايكم؟ هذه ergodic random process ولا لا؟ a third student، هذا التايم طبعا. اوكي، هذا شوي شاطر ما شاء الله، بس الليغ تسموه consistently، بس خبص في سمستر واحد، بعدين he's doing well الباقي مثلا. اوكي، ايش رايكم؟ is this ergodic random process؟ يعني ايش معنى ergodic random process؟ if I look at the average GPA of all students. Okay, the average GPA of all students, compare it to I look at only one student and I calculate its average GPA over different semesters. ايش رايكم؟ حيعطيني نفس الرقم ولا لا؟
لا دكتور.
لا، ليش؟ اول شيء لانه there's no long enough time، هي 8 سمسترات ما في اكثر. So you cannot observe one student for long enough time, and because of that this is not an ergodic random process. Okay, this is not ergodic لأنه ممكن طالب يعطيك GPA منخفض، ممكن طالب يعطيك GPA عالي، لكن if you look at all the students you will have the average GPA of KFUB مثلا 2.5 ولا 2.7 ولا ما أدري كم. تمام؟ لكن one student will not give you the same time average. طيب شباب، any question؟ Okay. Now the last thing I would like to talk about is the measurement of correlation function. Now if you would like to measure really in the lab a correlation function, you need basically to measure زي ما قلنا تسوي many realizations, and you look at the signal at different times and you multiply the values and take the average, and then keep shifting tau and do this same again and again until you get Rxx of tau, which is extremely difficult to do. However, using the ergodicity, you need to do it basically using time. So basically you only use or calculate the time correlation function. هنا مثلا we are looking at the cross correlation function. You can do the same thing for the autocorrelation function. We are looking at two signals here, x of t and y of t. We delay one of them by tau, and we multiply them. So basically, we calculate R0 of t plus t1 here is just a reference time. Okay, that's starting point خلينا نقول. we calculate it as x of t multiplied by y of t plus tau, integrate over 2t period and divide by 2t. Okay. Make sure that t here is long enough. اللي هي الكابيتال T. That's it. So if you start at t equals 0 and you assume t is very large, then basically r0 of tt will be equal to or approaches the time or cross correlation function. And because so this is if t is long enough.
Doctor, is there a definition for long enough or number of samples, or it is by practice?
خلينا نقول long enough معناها long enough until this doesn't change. يعني خلينا نقول المين التايم افريج. انت you observe the signal for a certain time مثلا خلينا نقول 1 minute. Now if you increase ال 1 minute خليها 2 minutes هل يتغير التايم فانكشن التايم افريج؟ إذا بدأ ما يتغير خلاص معناها this is long enough. It's not changing. هذا هو الافريج خلاص. نفس الشيء هنا long enough طبعا مع المدة الناس تعرف how long تعتمد على كم الماكسيمم فريكونسي. إذا السيجنال تتغير بسرعة معناها t might be يعني إذا خلينا نقول you don't need very long t لكن إذا t تتغير إذا السيجنال تتغير ببطء you need longer t. Okay. So basically if t is long enough this r2t r0 of t will be equal to or will approach the time cross correlation function. And because of ergodicity it will approach the ensemble cross correlation function. Let's have an example of this. So here we have a system to measure the autocorrelation function of x equals a cosine omega 0 t plus theta. تذكروا هذا اللي. So basically we take x of t and we take here x of t delayed. So here it will be x of t delayed. Because we are interested in the cross correlation function, the autocorrelation function. So r0 of t 2t will be the integral of cosine اللي هو x of t multiplied by x of t plus tau. And we have here a squared because we have the amplitude multiplied twice. So this is x of t and this is x of t plus tau. And you integrate from minus t to t, divide by 2t. Now, cosine, we can write it as half cosine the difference, cosine the sum, plus cosine the sum. Okay, and if we do this the integration, you will get basically a squared over t over 2 cosine omega 0 t. هذا أول جزء. الجزء الثاني is a squared over 2 cosine omega 0 tau plus 2 theta. However, احنا تتذكروا when we calculated rxx of tau طلع عندنا half a squared over 2 cosine omega 0 tau. We did it before. لو تتذكروها. So basically this looks like the ensemble autocorrelation function plus some error. This is an error. Now if we require the error to be at least مثلا 20 times less than the largest value of the true autocorrelation function. So the absolute value of the error is less than 0.05 the maximum value of the autocorrelation function. مثلا يعني هذا an example. Which means what? It means that the largest value of the error اللي هو هذا الأحمر is less than 0.05 the largest value of the autocorrelation function. Now simplifying get you T should be larger than or equal 10 over omega 0. زميلنا اللي سأل how long T should be. Well, it depends on your frequency. إذا الفريكونسي عالي معناها السيجنال تتغير بسرعة, you will have to have smaller T. But if the signal is changing very slow, معناها الفريكونسي is small, you will have to have larger observation time. هذا اللي هو لما نقول wait enough time. وضحت الفكرة يا شباب؟
واضح يا دكتور.
طيب, so we are left I think with هنا عندك ال for t equal 20 نفس الاكزامبل اللي فوق, t equal 20 وهنا عندك t equal 50. So when we calculated this, we get basically we have to have 50. So when we have to have 50 and we have only t equal 20, you can see that there is an error. الإيرور كبير هنا. الإيرور أكبر من 0.05. And this is the error. نشوف كيف الفرق بينهم. بينما when we allow it for enough time حسب ما حسبناه اللي هو t equal 50, we have it almost exact. The error is very small. So when we do the calculation أعطانا 50, لكن في أول experiment سويناها 20, which is not enough, عشان كده طلع في فرق كبير. هنا طلع ممتاز. I think time is up. You have any question يا شباب؟ طيب, we are left with only one slide here. Next time we'll continue, inshallah. And then we'll start chapter 7. Time is up. Those who would like to leave, you are welcome to leave. And anybody has a question?
جزاك الله خير دكتور.
إياك إن شاء الله. الله يسلمك. So we'll see you on Sunday, inshallah.